A carboxylic acid has that carbonyl C double bond O carbon. The carbonyl carbon is single bonded to an alkyl group, and it is single bonded to an OH. To name an acyclic molecule with one or two of those carboxylic acid functional groups, also abbreviated as COOH, like I have in my notes, these are the steps that you're going to follow. You're going to name the parent structure, which of course, you should know this by now, is the longest carbon chain that includes the C double bond O, or the carbonyl carbon. If you just have one COOH functional group, you're going to drop that E from the parent structure name and add the ending oic acid. So that's OIC space acid. Remember, spaces are important. And then if you have two of the COOH groups, you leave the E on and you add dioic space acid. You would, of course, find and name any substituents that you have on your parent structure, and then add locants. Like many of the functional groups that we've talked about before this, the carbonyl carbon has the priority for numbering, but you don't need to include those terminal locants. So one carboxylic acid is always going to be 1 because it ends the chain, and 2 carboxylic acids are always going to be on either end of the chain, so their locants are understood and they can be omitted from the name. So this example has 1, 2, 3, 4, 5. Oh, I actually did something different than a hexane. This is a pentane parent, and so we drop that E and we add oic acid. So this is pent and oic space acid. And that's the full name of that molecule. We don't need to add locants because they're understood. Pentanoic acid. Here's another example where we have a diacid. So we've got 2 of the COOH functional groups. So we'll find the parent chain, including both of those carbonyls. 1, 2, 3, 4, 5. So again, we have a pentane. And then we can just add dioic acid. So pentane, dioic space acid, and then we have a substituent on this one, so a chloro. And we need a locant for the chloro, so let's number 1, 2, 3. If we had started on the other carbonyl, we would also get 3. So this is a 3-chloro. I'll just put the rest of those numbers in so you can see that the carbonyl carbons for this dicarboxylic acid are 1 and 5, but we can still leave them out. It's still understood that they're on the first and the last of the chain. So we'll just add our 3-chloro to the beginning of the name. 3-chloro pentane dioic acid. If you have more than 2 COOH groups, or if the carboxylic acid is coming off of a ring, then you wouldn't count those carbonyl carbons in the parent structure. And instead, you're going to just use the ending carboxylic acid instead of oic acid. And again, just like the examples previous to this, that signifies that you didn't count the carbonyl in the parent structure. So this example has a cyclohexane ring. So cyclohexane. And then we can just put carboxylic acid. Carboxylic space acid. And since there's nothing else on the ring, we can omit the locant 1 here. If for some reason you can't get your carboxylic acid into the parent structure, you're going to name it as a carboxy substituent. So in this example, we have 3 carboxylic acid groups. Here they're abbreviated COOH, which is pretty common, especially when you have bigger structures. So if you see this, just know that the COOH means C double bond O, OH. We can name this sort of big long chain here as our parent, and then that way we can get 2 of the carbonyl carbons in the parent structure. So it's easier to forget when they're abbreviated like this to include them in the counting. So don't forget that. We'll include this carbon, and then this whole thing, including the carboxylic acid, will be a substituent. So let's find out how many carbons there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 carbons is nonane. And 2 carboxylic acids is dioic acid. So we've got nonane, dioic, space, acid. And then this substituent has 1 carbon here. And then on top of that, we have the carboxylic acid as a substituent. So we have the carboxy. I'm just going to erase this nonane here so we don't get confused. So the carboxy substituent, the COOH, and that is on top of a methyl. So a carboxy methyl substituent. And carboxy methyl, because it's a complex substituent, will be in parentheses. So carboxy methyl nonane dioic acid, and we just need a locant for that carboxy methyl. So if we go this way, 1, 2, 3, 4, 5, and if we go the other way, 1, 2, 3, 4, 5. So it doesn't matter. And so this is going to be 5 carboxymethyl nonane dioic acid. So a couple of more practice questions with carboxylic acids just to get us through. Then we're almost done this whole section. Can you believe that? It's been a lot. All right, this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, including the C double bond O. So another 9 carbon chain. So nonane, but because there's just 1 carboxylic acid, we'll drop that E. So we've got non-anoic space acid. And then in terms of substituents, we have an OH. And remember, when it's a substituent, because it's less important than the acid, and the OH is named as a hydroxy substituent. And we'll number starting at the carbonyl. So we get a 3 for that hydroxy. So all together, 3 hydroxy non-anoic acid. And lastly, we have this carboxylic acid bonded to a ring. So the ring is going to be the parent. It is a cyclopentane. And then you just add carboxylic acid. And then there is a big long alkyl substituent on this cyclopentane as well. So let's count 3, 4, 5, 6, 7. So that's a heptyl substituent. And the carboxylic acid is 1, which makes the heptyl a 3. Oops, delete that. There, 3 heptyl. So 3 heptyl cyclopentane carboxylic